Number 5, use the notation. The notation is an ordered pair. The first component, independent variable. Remember, it's x. Second component, dependent variable, which is y. To characterize the relationship between time and the temperature of a cooling object. Between those two variables, time and temperature, which one do you think is independent? Is there anyone could control time? Yeah, so if you have time in the two variables, time is always the independent variable. Nobody would control time, okay? Time would be the independent variable. The temperature would change as the time passed by, right? For a cooling object, when the time passed by, the temperature would go down. So it's a decreasing function. We should choose B. Time would be the independent variable, and the temperature would be the dependent variable. The other three do not make sense. As I said, if you have time, if you have the variable time in the function, in the two variables, time is always would be always the independent variable. Number 6. Okay, so we have the information here. An experiment is conducted and the following data points were recorded relating time in hours and amount of a drug remaining in the bloodstream. So we are told this is a function, because you can see for each domain element there's only one range element. The function has 1, 2, 3, 4, 5, 6 ordered number pairs. We're going to answer the following questions based on the function, the information given up front. The first component, what does the first component represent? Time, right? Remember, if we have time in the two variables, time of course would be the independent variable. So after 1 hour, there is 10, what's the unit here? Milligrams, yeah. So after 1 hour, there is 10 milligrams drug remaining residue in the bloodstream. After 3 hours, the amount of drug remaining becomes reduced to 9 milligrams. After 5 hours, the amount is 7 milligrams. After 6 hours, the amount is 5 milligrams. After 7 hours, there is 3 milligrams drug remaining in the bloodstream. After 9 hours, 1 milligrams left only. So that's how do we understand this function, okay? Number 6, how many milligrams of the drug remain in the bloodstream after 5 hours? So the time here is 5 hours. So we need to find the input is 5 hours. So we need to find the ordered number pair which has the first component which equals 5. Is this one, right? The corresponding output is 7. So after 5 hours, there's 7 milligrams residues in the bloodstream. Number 7, after how many hours should the concentration of the drug be 3 milligrams? So we are told the output. We know the output is 3 right now. We need to find the input that gives the output 3. So this ordered number pair has the output 3. Second component is 3. The first component is 7. So we know after 7 hours, the concentration reduced to 3 milligrams. 7 hours. Number 8, if you were to graph this relationship, which variable would be plotted on the vertical axis? We have ordered number pairs in the function, right? So it is going to be a two-dimensional graph. Two-dimensional space are formed by a baseline, x-axis, and a vertical scale, y-axis. Which variable you're gonna plot on the vertical axis? We're gonna put outputs or the dependent variable, the values for dependent variable in the y-axis. And we're gonna plot the values for the independent variable on the baseline. So we should choose amount of drugs. All right, that's always like that. Actually, the graph with the baseline as time is called a time series. Yeah, we actually talked about time series before, right? So this is number 8. I want to talk about how do we understand the domain and the range if the function is represented by a graph. Let's try this function. This is a function we agree, right? What's its domain? What's its range? Domain of a function is the set containing all the first components of the ordered number pairs in the function. So it's gonna be -2, -1, 0, 1, 2. 5 members in the domain. And the range by the definition is the set containing all the second components in the ordered number pairs of a function. So there are 2, 1, 0, 2, 1, 0, 1, 2. Here, 1 appears twice, 2 appears twice. In a set, if we have repeated numbers, we only write it once. So the range here only contains 3 members. There are 2, 1, 0. From this example, we could see the size of the domain and the size of the range do not have to be the same, right? In this example, the domain, both domain and range are finite. However, there are 5 members in the domain, 3 members in the range only. Let's look at this function. We agreed earlier, this straight line is a function. And I want you please find the domain and range for me, for the function, for the straight line. By the way, this is a linear function, okay? Linear function. We are going to talk about linear function soon. Linear function. So what's the domain? What's the range? By the definition, domain is a set containing all the x values, right? All the x values, all the first component. So for this point is on the line. This point has x value 0, right? And those points have x values bigger than 0. And those points have x values less than 0. So we have so many different points. Those points, uncountably many points. So what's the domain? Do we have a finite domain or infinite domain? The domain is infinite. It has infinitely many, uncountably many numbers in it, okay? So the domain actually is all real. All real. All the real numbers. That's the domain. And what about the range? For this number, the y value is 1, right? And for this number, for this point, y value is 0. All the points above that point, they have a y value bigger than 0. All the points below that point, they have the values less than 0. So you can see the range is all real as well. Negative infinity to positive infinity in the interval notation. All right, here, assume this point is -2. How about that? Okay, so can you help me to find the domain and range for this parabola? Domain is the set containing all the first components of the ordered number pairs in the function. In other words, the domain is the is all the x coordinates of the points on the problem. We can tell this point is on the problem. It has x value 0, right? And all the points to the right of that point, they have x value bigger than 0. All the points to the left of this point, they have x value less than 0. So the domain, infinity, infinity. So the domain is all real. The two arrowhead means the parabola is extending to both directions, right? All real. What about the range? What about the range? This point, these 2 points actually, they have the y value 0. Range by the definition is the set of all the y coordinates of the points on the problem. Second components of the ordered number pairs in the function. As I mentioned, the 2 points, those 2 points, they have the y value 0, right? All the points above, they have a y value positive. All the points below, they have a y value negative. However, do you see the y value has a lower bound, -2? Do you see any point on the problem would have a y value less than -2? No, right? Because -2 is the minimum of the function. No graph, no part of the graph below -2. So the range actually is all real numbers bigger than or equal to -2. All real numbers bigger than or equal to -2. No less than that, because we have nothing below. This is the notation, interval notation for the range. We use bracket to frame 2 because 2 is -2, sorry, -2. -2 because -2 is included in the range. Okay? -2 to all the way to infinity. If I challenging you a little bit more, let me give you another problem here. And this time I don't have the arrowhead. Instead, is the graph, the function actually is part of the problem. Okay, so this is 2, 2. This is -2, 2. This point is -0, -2. 0, -2. Okay, anybody could help me to find the domain and range? This is a very important skill, important knowledge that you need to grasp about the function. Domain and range are the two very important elements when we define a function. So what is the domain? All the possible values for x. Okay, all the possible values for x. This is -2, this is +2. Okay, so this point has x value +2. This point has x value -2. And no points, no graph to the right of 2, no graph to the left of -2. And other points on the graph have x value between -2 and 2, right? So that gives us the domain actually is a closed interval, -2 to 2. In other words, the domain is all the real numbers between -2 and 2, including -2 and 2. Range, all the values for y. So this point has a y value -2, right? And we should understand that's the minimum value. What about the maximum value? +2. It doesn't go up, doesn't go beyond. The graph do not go beyond. The graph doesn't go beyond 2, y equals 2, right? This is y. This is y equals 2. Right? So these 2 points have a y value 0. And those 2 points have a y value 2. And those points have a y value between 0 and 2. and those points has a y value between 0 and -2 and 0. So you would see the y value are between -2 and +2. The range is also happen to be -2, 2. Any real numbers between -2 and 2. Okay? I hope you can really grasp the domain and range. It is very important for learning mathematics. Okay, so this is section 9A. I'll see you next section. Thank you for watching.